Earthquakes are one of the most destructive natural disasters and is the shaking of the ground due to the movement of the Earth's tectonic plates. In this video, we are going to explain the 3 most important aspects a civil engineer needs to consider when designing for an area prone to earthquakes. An example of this kind of area is Mexico City, where in late 2017, an earthquake of magnitude 7.1 caused the collapse of more than 40 buildings and the death of 370 people.
The first factor we consider is geotechnical engineering. Depending on the type of soil, an earthquake could cause soil to behave like a liquid. This is because the vibration of the earth would cause less dense soil to rise and denser soil to sink. This phenomenon, also known as liquefaction, leads to buildings built on top to sink as well. To avoid it, buildings could either use a stronger foundation mat or have longer foundation columns that reach deeper into the ground. This increase in surface area also makes it harder for the buildings to sink. Landslides are another major problem. It is when soil on a slope slides down towards the bottom and results in the destruction of buildings and properties below it. To address this, we can spray concrete on the sides of the slope and insert plastic tubes. The concrete has an obvious purpose, but the polymer tubes are placed to allow rainwater to flow through. Therefore, after heavy rain, the mass of the slope does not increase drastically and cause the concrete to break.
Next, we have to consider structure engineering. When a person stands on a slab, their weight is transferred from the slab towards the beam, then columns, and finally towards the foundation. A building is most likely to collapse when the columns are weaker than the beams. This causes failures to occur in the columns before the beams, meaning the users of the building have a risk of being sandwiched by the 2 floors that they were originally supported by. This commonly happens in the first floor of buildings because of the usage of large windows for businesses, causing the building structure to become weaker. So unless you want to be sandwiched as demonstrated, engineers have to design buildings for failure. They do this by designing beams to be weaker than the columns of the building. This means that even when the building fails, it will not immediately kill the users within, giving them time to escape.
Finally, we have to think about transportation engineering. Knowing what to do and where to go during an earthquake is very important. Many become trapped in buildings or even get killed because they don't know the correct places and the correct ways to evacuate. After an earthquake, roads and essential infrastructures are likely to be damaged or even completely destroyed. This makes it harder for rescue to arrive and treat the injured. The most effective solution is, of course, preparation. This includes education, preparing temporary shelter, deployable emergency foods, and medical equipment.